Welcome back everyone, my name is Dustin, and in the last video we were able to get the collision system working, where we can actually tell when we're colliding with another object. However, we're not doing anything with it yet, but we're going to do that soon. But at the end of the last video, I also left you with a small challenge to create the projectile class. If you're able to get that done on your own, awesome. Post a comment below, and if you were not able to do it, that's alright. We're going to go over how to do that now. So the first thing that we're going to need to do is to create a new file that will hold our projectile class. And we'll do that over here in our Asteroids folder here, and new. And that's just going to be called projectile.lua. But so the first thing we do is we create our namespace, or projectile is equal to table, then projectile index is equal to projectile. Then we go function, projectile, create, and we're going to want to send in the params. And we can say local this is equal to, and then set meta table. Might as well get this stuff out of the way. This to self, and then return this. Okay. So the first thing we're going to need is our actual definition. What type of projectile is it? And that'll just be params.depth. Basically this here is just a holder if we have to grab the depth again. We probably don't need it, but that's alright. Then we're going to need a direction, and that's going to end up being a vec2. So params.dir. And we're going to have to make sure that's a vec2 going in. We're also going to need the start position. Where does the projectile start from? So we'll just call that mstart pause. That's also a vec2. Params.start pause. And then we also want the rotation. Not that the projectile is going to be rotating, but we need to know so we can change it for the sprite. Params.rotation. All right. So before we continue anymore with the projectile, we're going to need to go and create projectile defs, or at least start the defs, similar to our entities, like how we do the ship. So let's go to our entity defs file, entity defs, and add a new table for the projectile defs. So we'll do that here. We'll go projectile defs. That's a new table. Let's make sure we put equals there. Okay. Now we treat the projectile defs just like any other entity. So we need the group, the components, and any other extra stuff that would be specific to a projectile, like lifetime and speed. So we'll call the first one just projectile1, or just proj1, because we may have multiple types of projectiles. That's just another table. We'll say group is equal to, this one is just going to be projectiles. And then components. And what kind of components are we going to have? Let's have all of these. Basically the same thing as the ship. We'll just copy all this. Paste that in there. All right. So we'll just have our transform position start at 0, 0. Scale 1 to 1, rotation 0. Now we need to actually have a projectile sprite now. So in the same assets pack that we've been using, we need to go pick one. And I've already done that for me, and that one is this here. It's just this one right here. I called it projectile 1, and it's just a simple, easy projectile, and its size is 32 by 16. So we'll go back here, and that's 32 width by 16. And we're going to call this one proj1 when we load it in our asset manager. Proj1. Now we just got to make sure that it's in our folder. And we got it in there. Now that we have our texture, it's going to be layer 2. What do I want the radius to be here? Well, the height is 16, but we're just going to make this one actually 12. 12 will be good for this. Maybe 16. Nah, 12 is good. We'll put it to 12. If we got to change it later, we'll change it later. All right. Is this extra? I think that's extra. Cool. That's sometimes the issues when copying things over. All right, so other than the components here, let's add a lifetime. So lifetime, we'll start that at 2000. That's in milliseconds, so 2 seconds is the lifetime. And then the speed, so proj speed, we'll have that to be 10 for now. Okay. So let's go into our asset defs here and make sure we add in our projectile. I'm going to call it proj1. Proj1, and that was projectile1. Projectile1. Awesome. All right, so now that we actually have our projectile defs, let's go local projectile is equal to projectile defs at this dot mdef. And then let's just assert that the projectile exists. All right, and now we want to do the entity ID. So this dot m entity ID is equal to load entity, and we're sending in our projectile. So it's sending in our projectile def. All right, so now that we have our def loaded, we need to add a few more variables, so, like the projectile lifetime and the speed that we just added. So let's do that. So we'll go this dot m projectile lifetime is equal to projectile dot lifetime. And then we want to say this dot m speed is equal to projectile dot proj speed, and we'll say or 10 if it's not provided. Same with this one. Let's just say or 2000 if it's not provided. Okay. And we're also going to need to have a timer that will monitor how long the projectile has been alive for. So we go this dot m life timer is equal to a new timer. So now the last thing we need to do is set the projectile's position and rotation to the position that was set in for the parameters, to its start position. So we go local projectile entity is equal to an entity this dot m entity ID. Then we go local transform is equal to project ent get component transform component. Now we want to set the position. So transform dot position is equal to this dot m start pos, and then transform dot rotation is equal to this dot m rotation. All right, now we want to start the timer. So we go this dot m life timer start. Awesome. So that's basically all we need for our projectile here, for the creation of a projectile, that is. And now we need to update it. With the update function, all we really want to do is update the position of the projectile. Everything else will be done in another place. So we go function projectile, and we'll just say update. And we're just going to get the projectile again. You might as well just copy all of this here. Cool. So we get the component, and we want to just set our position. So transform dot position is equal to transform dot position plus self dot mdir times self dot m speed. And remember, the dir is, or direction, is a vec2. Okay, and that's it. That's all we want to do for our update function. We may do some other stuff later on, but that's all we need for now. And we have one more function that we have to do that I forgot. We need to go function, and we need to check to see if the projectile is past its max lifetime. And we'll just call this times up. So projectile dot times up. So all this is doing is checking to see. So return self.m lifetimer elapsed milliseconds is greater or equal to self.m projectile lifetime. That's it. Awesome. So now that we have that done, let's go to our ship and try to fire some projectiles. See if we can get this working. So we'll go to our ship, wherever that is, ship.lua, and we'll just do that in update ship right here. We're just going to add in, if we hit the space bar, we would create a projectile. All right, so if keyboard dot just pressed key space, then local projectile is equal to projectile, create. And we want to create a new projectile here. So we'll say, and this takes in a table. So it's the params is a table, and we'll call the def. We're going to send proj1. That's the one we want it to be at the current moment. We might end up changing it where you can have some upgrades and you can change the type of gun that you're shooting, but that would be later on, or that would be a challenge for you guys because we don't want to keep making this game forever. And then, okay, so our direction, and it's a vec2, and that's just going to be our forward direction. And then we want to have our start pause. Start pause is equal to a vec2. And we wanted it to start from the middle of the ship. That's what I wanted to do. So transform dot position dot x plus half of the sprite's width. So sprite dot width divided by 2. And we basically want to do the same thing here, but for height and y. And y. And for the rotation, it's just the ship's rotation. So rotation is equal to transform dot rotation. All right, that's it. And we should be able to see that now. See if that's working, but we have to load the file. So right here, we have to load our new projectile.lua. Projectile.lua. Let's run it and see if it works. All right, so we got some errors. Okay, so let's see those really fast. Ah, yes. So at ship 58, it's expecting an end function. Let's go back into, or not end function, it's looking for the end keyword. And that's because we had a new if statement here. We didn't put it here, so we have to put end. Okay, and let's try again. Put a little space there. Awesome. Cool, it's creating them. They're not doing anything, but it's creating them. Awesome. Look how slow that gets. So what we're going to do is we're going to get rid of all this colliding stuff here, or we can run it in release. Actually, we'll leave the colliding stuff for now, and let's just change this to release mode and see if it even builds. That's one thing we haven't done to see if we can build this in release. So it's good to check every now and again. We may have some bugs, so let's check it out. Okay, so we have a problem here, and it's in the create timer function. So no, we don't want to build it. So let's go back to where we create our timer, and that's in our scripting system. Here, create timer. And what was the error again? The output is this. Okay, so this is having a problem with our soul factory wrapper here. So we have this soul factories. We can change this instead of use the factories, we can use soul constructors. So we go soul constructors. And you can put multiple constructors in this way. And that's what we'll do. Like that. And then this here. And let's see if that works for us. Get rid of that. Okay, so now we're just calling because we only have a default constructor. Let's see if that works for us. All right, looked like that worked for us. Cool. And we're creating and it's obviously it's colliding because I'm on them right now. So it's seeing that we're colliding with them. Great. Cool. That's exactly what we want. But now we want to actually get these updating. So let's close this down. Okay, and that's in our release build. We can debug in release. However, sometimes the compiler will change the way that things are, actually a lot of the time. So you can't really debug very well in release mode. So if anything, we'll just go back to debug mode if we have to do debugging of the actual engine code. All right, now that we fixed that, we want to go and add in basically how we did the asteroids. We want to have a holder that holds on to our projectiles. Basically the same idea. that here. So we'll just go projectiles, and that's just going to be an empty table. And then we're going to basically do the same thing here. So let's just grab this and change that. However, it's a little bit different. So what we're changed here is we just change this to projectile, change this to add projectile, change that to projectile. All right, and we're going to want to update projectiles. So update projectiles. All right, just like that. So when we're doing our loop through our projectiles, the first thing I'm going to want to actually do is see if the time's up. So if time's up for my projectile, then I'm going to want to do some stuff in here. Else we update. Okay. What we didn't make is a destroy function, which we could do. So we want to go v destroy, which it will destroy the projectile. And then our projectiles at k, we want to set to no. All right. So let's go create this destroy function right now. So we know to destroy the projectile. And that'll be in our projectiles function, or projectiles class, sorry. So function, projectile, destroy. And now the projectile destroy is pretty straightforward. We're just going to want to say local projectile is equal to entity. Let's get the underlining entity ID, and then just kill it. Projectile, kill. Bang, that's it. That's the destroy function and the update function. So let's go back to our utilities and we'll say, so we have our update projectiles, and we'll take this and put it into our main.lua. Right under asteroids, we will update our projectiles. Okay, let's run this and see if they move. And they're not moving. All right, so why? So in update projectiles, it's saying basically it's not even updating them. Ha! Yeah, that's silly me. So yeah, it is doing it, but we never ever called add projectile. So let's go back into our ship, and we're creating this projectile here, but we're never adding it in. So we just go add projectile and just send in the projectile. Projectile. Okay, let's see if that works now. And we have an error, which is fine. Elapsed milliseconds. It doesn't know what that is. Projectile time's up. Elapsed. That's the problem. Spelling errors. So here in time's up. Oh, not here. That's ship, sorry. So go back to projectile. In the time's up, this should be elapsed milliseconds like that. Okay, let's run it again. All right, another error. So global this, so projectile 33, projectile 33, this, self. You guys probably already caught that error. Run it again. And space, there we go. There's our projectiles. So they're colliding. They're going where we want them to. Now, we don't know if they're being killed, but looks like it's going good. So we got our projectiles going, all right. But it's not doing anything, just giving us some data for what's getting hit. So now, let's actually do some stuff with that collision data that we're getting. Okay, awesome. So we got our projectiles firing, and we're colliding. All right, so in our collision system, we have a little bit more we want to do here. We're intersecting, that's great. And the first thing we want to do is just check. So if group A is equal to projectiles, and group B is equal to asteroids, then what we're going to want to do is set our colliding, collider A dot B colliding is equal to true. What that will do is it'll skip it next time around because it's already colliding with something. Collider B dot B colliding is equal to true. And then we're going to want to get rid of our entities. But we don't want to kill them inside of this double for loop, this nested for loop here, because it may still be referencing it inside of this data here. So what we need to do is create another table, and we're going to call this entities to destroy. So we'll say local entities to destroy. And that's just going to be an empty table for now. And then we're just going to say table.insert entities to destroy. And we're just going to send in the entity B because it is an asteroid. So entity B, and we're going to send it in by its ID. We're just going to hold on to the IDs. The reason why I don't want to hold on to the projectile is once we set it to colliding, it's not going to collide with anything, and it should die on its own based on its destroy or its time's up timer. Okay, so we're going to do the same thing, but swap them. So go here, copy this. Oh, we still want that. Else if, and then change this to B, or this should be A, sorry. And copy these again. And this one's going to be A, because we're sending in the asteroid. Let's copy the whole bunch here. And we're going to do the same thing for ship, but we're going to change this to tag A, or do we call it name A? Name A. Name A ship. Then we only care about A colliding, because the ship and the asteroids, the way that I'm going to do it is the asteroids do not get destroyed by hitting the ship. So they're still going to be alive. And we'll copy this again and change it to B. This should be B here. And that should be A. This should be B. Only B colliding. And then this would be entity B. And then we could say end and get rid of this. Cool. So that should work for us. And then down here at the end of the double loop, now we want to loop again through our entities to destroy. So for K, V in pairs, entities to destroy, do. Then we're going to want to get the entity itself. Local entity is equal to entity at V, because V is just the ID. And then once we have the entity, we want to go if entity group is equal to asteroids, then to do something here, else if entity name is equal to ship, then to do. All right. And another end here to close it off. Okay, so now we don't want to just kill them right here, because there's other things we want to do, okay? Let's do the asteroids first. Now we're going to create a new function, and we're going to call it remove asteroid. And that's going to take in the entity ID. Okay. So let's take this remove asteroids function and put it into our utilities with our other asteroids function. So here we have our spawn asteroids, update asteroids. So right after update asteroids, we'll have the remove asteroid. And this is just going to be a function. And this is going to take in the asteroid ID. We'll say asteroid ID. And end. Okay, so now we're going to want to do the same thing. We're going to loop through all of our asteroids, 4K, V in pairs, asteroids, do. Now we're going to check to see if the asteroid at K, value V, has the same entity ID. So we want to say if V dot M entity ID is equal to asteroid ID. Then end. Okay, so now we're going to want to check the asteroid's type. Check the asteroid's type. Okay, let's go make sure that we have a way to do that. So does it have a type? Did we give it a type? Yes, type. But we don't have a way to get it unless we just go .type, or we can say get type. And the asteroid types, let's go to our entity defs. That's asset defs, sorry. Entity defs here. And our types are small and big. Cool. So if we go back to our utilities, and if we go if v.mType is equal to big. So if it's a big asteroid, and then else if v.mType is equal to small, and then end. Okay. So what we're going to do here, now we want to create 2 new small asteroids from a big asteroid. So what we need to do is go create small from big. That's what I'll call it. Small from big. And it's going to take in V. So it's going to take in the asteroid itself. And then we'll have another one to do. Add score. And then the small one, we'll just add the score here as well. To do add score. So before we go to create small from big, once we get to here, we want to kill the asteroid regardless. So if it's a small or if it's a big asteroid, we want to kill it regardless. So local asteroid is equal to entity v.mEntity ID. Then we want to go asteroid kill. And then we want to say asteroids at k, because that's where we're at right now, the current iteration, is equal to nil. Okay? So we're killing the asteroid here, and then we need to create a small from big. So let's create another function here, and we'll say function, create small from big, and that just takes in the asteroid. Okay, so what does the small from big function need? It's going to need the transform of the current entity. So the current asteroid, so go local transform is equal to entity, and we're sending in the asteroid dot entity ID. And we want to get the component of the transform component. Okay, then we got to go for I is equal to 1 for 2 iterations. We want to do something. Okay, so what we're going to do here is go local small is equal to asteroid create def is equal to, what did we call these? Asteroid big. So we don't have the def, we just go by the name. Okay. And we don't want asteroid big, we want asteroid small. Okay, and then we want to get the small transform and change it to the current transform of the big asteroid. So local small transform is equal to entity. Basically, we can copy that. And this is just small because small is an ID. Or so we want to get the small.m entity ID transform. Okay, and then we want to set the position to the transform position of the big asteroid. So we go small transform dot position is equal to transform dot position. Okay, and we want to add an asteroid. Add asteroid, and it's just the small asteroid that we're adding. All right, that should do it. That should add a new asteroid, but we're probably gonna have some errors. Don't think I'm missing anything. Let's try. So we have no errors yet. Bomb, killed it. Killed it. Cool. Let's see a big one. There's a big one. Boom, broke into 2. Now we can't die yet, and that's okay. Perfect. Awesome. So there's another problem is we can just spam the gun and shoot total spam. No, it doesn't stop. So let's actually put a cooldown timer so we can't just go crazy with the projectiles. So I want you take a second, pause the video, and try to add in a cooldown timer for us for the ship when it's taking a shot. Take a second and try that now. All right, hopefully you took a second to do that. And up here, we can add a few things. We're gonna have a cooldown timer. So put a comma here, and we can say cool down timer is equal to timer. And we're also going to want to have the cooldown time. And we'll put that in. So cool down. We'll just say cooldown. Cooldown, and that's going to be a time. And we're going to get that from the def. So def cooldown. If it's not provided, we'll just have it to be 150 milliseconds. Sounds about good. Now that we have our timer, all we want to do is come here and prevent us from firing if the timer is running. So we go, if not, self.m cooldown timer is running. Then down here, we can put this another n here. Let's move everything over a bit. Awesome. And once we do that, now we just want to start the timer. Self.m cooldown timer and start. Okay. And if it's not, if it is running, now this is where we want to check to see else if self.m cooldown timer elapsed milliseconds is greater or equal to self.m cooldown. Now this is where we reset our timer. And end. Okay. Nope, this doesn't need to end because there was already one there. Get rid of that. All right. So let's actually make this something big so we can tell if it works or not. Let's go half a second. So 500 milliseconds and run. And I hit the button too quick. It didn't like something. Right here. Syntax error, ship 64 near end. 64 near end. Forgot to put the stop in. All right. Yep. See, it's not spamming anymore. Cool. Maybe half a second is too long to wait. Oh yeah, way too long, especially if things are coming from all angles. Okay. So let's put this back to 150, or let's put it to 200 and see if that's more comfortable. Awesome, much better. Cool. All right. Okay, so now we have to think about the ship and how are we going to recreate the ship each time? No, that's not what we're going to do. Since we only have one ship and we're only ever going to have one ship, we'll just hold on to the one ship and we'll control it in another way. Let's create something that we'll call game data. And the game data will hold on to everything for us. It'll hold on to max lives, num lives, the score, the actual score of the game. Is it game over? Different flags like that. So we can work on that right now. So what we'll do is open up over here and create a new file. And we'll go add new item and we'll just call it game data.lua. Game data.lua. And basically the same idea. So we go game data. We're creating a new class. Game data dot index is equal to game data. And we're going to create it. So we go function game data create. Now this doesn't take anything because we're controlling it here. And then we'll say local this is equal to set meta table this and self, and return this. All right, so what we're gonna need our max lives. We'll just say like 5, and max lives is equal to 5. And then current number of lives is equal to m num lives. And we'll start that out at 3. Okay, and then we'll actually have a holder for the num asteroids. We're not going to be worrying about that right now. And we'll start that off at 0. And then the score. Okay, so let's create a few functions in here that will help us later on. We're going to need one function called function game data. And it will say is game over. And then just return self.mnumLives is equal to 0. Then we want to check the max lives. So function game data max lives. This is just going to return the max lives. And then the num lives, same idea. We can go ahead and just copy this. And then add life. So we'll go function game data add life. So self.mnumLives is equal to self.mnumLives plus 1. And then we're just going to want to clamp that. So self, actually we could probably put that in one function, is equal to clamp self.mnumLives 0 and self.mmax lives. See if that works. I think it'll work. And remove lives, we'll do the same thing. And then we'll just set this to -1. And then change this to remove life. Okay. And that's good for now. So we'll just say G data is equal to game data create. So we're just creating one right off the bat. Basically, we're going to have a holder for our lives, and we're going to remove lives and stuff. Everything's going to be from the main data. Okay. So now that we have our removed life, because that's really what I was interested in right now, and our G data, if we go to our collision system, we can add that in here. We go G data remove life. Okay, so what we're going to do first is we have to add in our G data or game data here, game data.lua, and let's just print out the number of lives. So we'll go print, and we'll say lives. We just want to see if this is working, and we'll say G data num lives. Let's just see if that works. So right now our lives are 3. Let's get hit by something. And it should decrement. If something ever shows up. There it is. 2. Cool. So it did decrement, but it didn't go any more because we set the colliding bit inside of here. So we need something to reset the colliding bit, okay? But before we get to that, we need to add in some other things to our ship. So let's go to our ship. So we know that we are colliding. We know that it's taking the life the way that we want it. So we're gonna actually add in another thing here, a couple things here actually, some more timers. So let's go down here and add in some timers. And we'll have the death timer. And we'll also have an invincible timer. So invincible timer. Don't know if I spelled that right, but that's all right. And that's equal to another timer. So what do I mean by invincible? When you first come back alive, you don't want to get hit right away because you could be anywhere. You could spawn anywhere. So you want to be invincible for a little while so you can get your wits about you. And we're going to have a Boolean value, MB dead. So are we dead? And it'll start out as false. Then we're also going to need the number of lives. So M num lives. And that's going to start out as G data num lives. Okay, that looks good. So right here in our update ship, we don't want to do anything if we're dead. So we just want to go if self.m be dead, then we're just going to return. This will leave that particular function. Okay. So right here, after we're done all this stuff, before we check the position, let's go self check death. We'll make a new function called check death. Check death. And we'll make that function right here. And we'll go function ship check death. We have a holder of num lives, so it sets our num lives to the current value of the game data. However, if the data changes, we want to know that. So we go if self.m num lives is not equal to G data num lives, then we want to, so we put our end here. Now we don't want to set our dead here. We set our dead if our lives are completely gone. So what we're going to want to do now is actually start our death timer and set our new lives to self.m num lives is equal to G data num lives. And start our death timer. Actually, for now, we're not going to start the death timer. There's a lot of stuff I want to put in here, but we're not going to do that for now. We're going to start our invincible timer. Okay? And down here, we'll say if self.m invincible timer is running, then let's get the sprite and change the alpha so he's lighter, so you know he was just hit. So this will be our invincible. So we'll get the sprite, and that's equal to our entity, self.m entity ID, get component, sprite. And then we're going to go sprite.color.a is equal to 150. Then here we're going to do another check. We go if self.m invincible timer elapsed milliseconds is greater than 3000 milliseconds. Then we're going to reset. Once our invincibility has reached 3 seconds, this is where we reset our collider. So now we want to get the collider. So let's do this here, so we don't have to keep making new entities. Let's make it right here. So we'll go local ship is equal to, let's take this entity here, call this ship. And down here, let's do local collider is equal to ship.get component, and that's the circle collider. And we'll say collider.be colliding is equal to false. And then we can stop our invincible timer and reset our color of our sprite back to 255. Our alpha value back to 255. Okay, so that's good there for this. Let's run it. So we have 3 lives. If we get hit, we should go to lighter alpha. And it didn't work. Good, and it stopped everything. Right here, field color. Nil field color. Did we not create the color? So let's go to our sprite component and check out. So we don't have access to our color, but we need to add that in. So our color. Now, I don't think we even made a binding for color. Let's see. No, we did not. Okay, so here, let's create a binding for our color. So lua.new user type. And that's going to be Scion rendering color. And this will be color. And this will be sol call constructor, sol factories. Now, how did we make our color? Let's go back. So it's just GLU bytes. So let's go back over here. R G B, ignore that, RGB A. And here we're going to return Scion rendering color dot R is equal to R dot G is equal to G dot B is equal to B and dot A is equal to A. Awesome. So there's that. And we have to go R, and that's Scion rendering color R. GBA. Cool. Now that we've bound our color, we can do this here and send our color. Awesome. Sorry, guys. I thought we already did that, and we should be able to see that now. All right. So let's get hit. Awesome. You see how our color changed? 1, 2, 3, and it went back. 1 life. Look at that. Perfect. So we're getting hit, and it's taking lives, and that would have been game over right there. Cool. Okay, so that's enough for this episode. This episode's gone a bit too long. I was going to add in explosions and stuff like that. So how about a little challenge where we add in an explosion? So what we need to do is you need to check death. And I was going to put the death timer in here and other things in here as well. But you want to check to see if it's going to explode. So if you get hit, you want to explode. And you want to start a different timer and try to see if you can change the animation to get it to go to an explode animation. So you need to go on Open Game Art and pick an explosion and set it up how you like. Or you can do another one and start the HUD. So we're going to need a heads-up display, something that has the score and the number of lives and stuff like that. And we got to keep track of the score. But don't actually worry about the HUD itself. Worry about just updating the score. So every time that you kill an asteroid, you're updating the score in some way. So what you can do is in your game data right here. So game data.lua, we have the score, right? So you can create a couple functions that will update the score based on what you send into it. Just a setter and getters for your score. And inside of your utilities, when you destroy an asteroid, add to your score, okay? Give that a shot. If you have any questions, leave comments below. I'll make sure to get back to you. All right, take it easy.